Now, our speakers today is interesting, are each concerned with different elements of the human waste stream, our relationship to it, our management of it, and in one case, or maybe a few cases, how we are endeavouring to transform it. And so that means that today's showcase is unexpectedly coherent because I didn't actually curate the theme, it's curated itself. This is the speakers who are joining us today are simply the intersection of the interesting people I meet, the ones I remember to ask if they'd be available to speak, and then the ones who said yes and are here today. So the theme has curated itself. This isn't the team we set out to collect, it's the team that we have got. But I think that that's really succinct commentary on the prevalence of human waste and, of course, therefore its growing prevalence as a research subject. So I'm glad to be able to introduce to you our first speaker, Mars Buttfield-Addison and I met recently as we were both preparing for National Science Week. We both found outreach easy. I know personally that all children have an insect phase, and I now know that all children have a space phase as well. And Mars and I were both lucky enough not to have to grow out of our insect phase and our space phase. Now, as a computer scientist, Mars has been pleased to participate in an incredibly wide array of scientific research, making machines do their magic. But as her PhD, she's focusing on adopting radio telescopes to track space debris during their standard astronomical observations, as it seems that the way we currently manage our orbital environment is about as responsible as we manage all of our other earthly environments as well. So, Mars.
Can everyone hear me okay? All right. Well, I'm very pleased to meet you. My name is Mars Buttfield-Addison, and I'm here to talk to you about why you should care about space junk. This is around my PhD topic, which is looking at how we can better address this in the future, but my PhD is a lot of really squirrely computer science topics. So I thought instead I'd tell you a bit of a story, because this is our orbit. And these are all the different things, these services that we interact with every day, that we use things in orbit for, and that we might not be able to do at all if we can't have satellites anymore. The reason we might not be able to have satellites anymore is because we've ruined our orbital environment to the point that if one errant collision might cause cascade collisions that would carry on until we're surrounded by a swirling debris field and can't put anything into or through orbit anymore. It would put an end to space exploration for maybe 100 years until we could figure out a better way to get these things down more than one piece at a time. But we look at this and it feels like we've only heard about this problem in the last few years. Like we all saw that Sandra Bullock film, Gravity, and we've heard the term Kessler syndrome now, the name for this idea that everything could just turn to crap up there. But it's not recent. This problem has come about through decades of compromises and people thinking it was someone else's problem or false assumptions, bad decisions, and I want to talk to you about that. For that, we need to go back in time. We can go back to 1950, where a famous mathematician and geophysicist went to visit some of his geophysicist colleagues in a town called Silver Springs, Maryland. They have a meeting and they talk about how isn't it so cool that these international polar year events, which got all of the scientific community from different countries to collaborate and move forward the needle on the cutting edge of science in polar sciences. Why can't we do that for geophysics? And they conceive of this event, this international collaboration event called the International Geophysical Year. The year is 1956, and the idea of the International Geophysical Year coming up the next year has caught on. A bunch of different nations have decided that they want to take part. Some of them have even started to say they might like to put our first ever man-made satellites into space. That's a big deal at the time, but we're also in the depths of the Cold War, and so to make sure that everyone is a good sport, we convene a committee called SAGI, and they have meetings to draw up guidelines and ground rules for anyone who wants to participate in this event. Namely, relevant to us, that you're not allowed to use any military hardware to participate in the event, and that anything you put into space is going to transmit on a certain frequency. The year is 1957, and the US, who everyone has just looked to as being solely responsible for tracking these new things we're going to put into space, has spent the last year or more making treaties with all different countries down North and South America, building these radar stations on foreign soil, and they all monitor the frequencies agreed upon by SAGI. Later that year, the USSR put their first satellite into space using a military rocket and not the frequencies we agreed upon, and Mini-Track can't see it. The year is 1958, and most satellite tracking worldwide is done by a network of amateurs that the US government has hurriedly tried to assemble by training people all over the world, using books sent out to them and phone calls, how to use often homemade optical telescopes to look at the sky, form these little clubs, and then they call a hotline to tell the operator when they've seen satellites in certain places. These detections are then compiled by hand, and a lot of mistakes are made. That same year, one of the first satellites ever put into orbit by the US, which will only function for about 6 years, but was put into such a stable orbit, it'll stay there for about 350. The year is 1961, and still in the Cold War, us humans decide that the most important thing on our plate right now is making sure that if someone cuts our undersea communications cables, that we can still communicate effectively to our troops stationed elsewhere. We decide that we want to up the reflectivity of our ionosphere for over-the-horizon radio communications. So what do? We come up with Project West Forward. We shoot capsules full of millions of tiny copper needles into space in these spinning spacecraft that were supposed to spit them out and deploy them all through the upper atmosphere so that radio signals can be brought back down, these tiny little antennas. But they don't deploy properly and instead just become clumps of needles that are still hanging around in space. That same year, after years of trying to fix Mini-Track, the US government go, no, we're going to scrap that. We're going to adapt some of those sensors, build a bunch more. They get a new space tracking network called STADAN. The year is 1974, and the USSR, sick of the US getting all the glory since Sputnik, decide that they want to do something fun. They've been launching these small space stations called the Salyut stations into space. They launched this one. It's secretly a military station. It's got a machine gun on it, an anti-aircraft gun. They decide to test it out by blowing a few satellites into pieces. It's 1975, and Europe goes, hey, that's not really fair that NASA is responsible for all of the tracking of spacecraft. We're going to make our own network, and ours will work. It's called S-Track. The year is 1978, and a NASA scientist who's previously been working on the formation of asteroid belts made from incremental collisions between rocks in space goes, hey, hang on. Isn't this how this would work with satellites? And everyone goes, whoa, man. Up until now, we've had the assumptions that A, space is really big. There is no way things are going to hit each other in space. And B, the drag on the upper atmosphere of satellites, which of course we'll only ever put into low Earth orbit, why would we put them any further, are going to drag so much they'll come straight back down. There is no way we could put something in such a stable orbit it will stay there for very long. Turns out, both of these things were wrong, and we were well on the path already to having the space debris problem. This idea of creating an unusable orbit was deemed Kessler syndrome after this man. The year is 1983, and still failing, the US decided to build a new space tracking network. This time it's going to have ground and space-based radar components called TDRSS. It's mostly coordinated out of the White Sands Missile Range. Goodbye STADAN, goodbye Mini-Track, hello TDRSS. The year is 1985, and the US, still posturing at the USSR and other countries that have ever dared to claim that they were as impressive as the US, decides that they're going to shoot a satellite out of orbit, just to show that they can, just so that every time they tell other countries that they better not put a surveillance satellite into orbit or put anything threatening in orbit, you will not use orbit for military uses, we only do that. They decide to send an F-15 going Mach 1 directly upwards and shoot with a missile a satellite out of the sky, and they create 285 pieces of debris from that one satellite of their own. The year is 1995, and even though we've already solved the global positioning problem by deploying the GPS constellation of satellites, we decide that that's not good enough, and a bunch of different countries start building their own, starting with the Russians have started with GLONASS in 1995, and having done that and duplicated the GPS network, everyone else goes, oh, well, we may as well also. So today we have 4 duplicated GPS networks that all do the exact same thing, and any one of those could do it by themselves. We also, that same year, NASA released the first international guidelines going, hey, this space junk thing, this seems serious. We really need to start getting on top of this. We're having rockets go up in multiple stages. Quite often the last stage stays in orbit. And They're staying up there. They were loaded with extra fuel just in case they didn't make it to orbit, or because we thought if the cloud cover was thicker than usual, we better give them spare fuel. Then they get up there and then they explode, and they're creating a lot of our debris is coming from rocket body explosions for things that have already done their job, taking whatever their payload was to orbit. We also know that people keep putting things in surprisingly stable orbits that get stuck up there for hundreds of years. So we're going to have these guidelines. One, if you take something to orbit in a rocket, it has to immediately vent out any spare fuel into space so that it presumably will have a much lower chance of exploding. And two, we have the 25-year rule, which is if you put something into space and it runs out of batteries at a certain date, or you plan to retire it at a certain date, you need to have a solid concrete plan about how within the next 25 years after that, you're either going to bring it up or bring it down. We have this new orbit called graveyard orbit that's about 500 kilometers past the highest usable orbit that we use today, and we decided that that's just far enough away that we're just not going to bother about it. That counts as gone. Otherwise, you bring everything back down. So within 25 years of something running out of fuel. The year is 2005. And the ESA has this big conference in Darmstadt, Germany, and they do a 10-year retrospective of how these rules have gone. They changed nothing. They did a study that showed that of all of the people that had agreed to abide by this 25-year rule and started making plans for how they were going to get their stuff back down out of orbit, 2/3 of them just didn't do it. And even more of them didn't do it well enough. So they pushed something out of orbit in a way that it just drifted back in, or they thought they were bringing it down, but they didn't do it fast enough, so it didn't, or they just ran it till the end of its life because they didn't want to waste that last bit of fuel that could make them money instead. So we had an incredible amount of rocket body explosions. Most of the rocket body explosions that have happened in human history in orbit happened after we made a rule that should make it impossible. The year is 2006, and the US goes, hey, that fighter jet thing was cool. Also, not on a slide here, there was a point where the US decided that if they want to shoot down satellites but they couldn't get a good enough pinpoint on them, they ran different tests called Operation Starfish, where they just nuked orbit on the assumption that it would cause an EMP pulse that would wipe out any satellites within 9 kilometers. And that was so impressive that we got a false aurora all across the Pacific Ocean. Thanks, the US. Anyway, 2006, they decide to once again shoot something out of the sky. This time it is a very large surface radar satellite. And they said, it's coming down, it's full of rocket fuel, full of hydrazine, we can't let that come down. And every other country's like, you've let a lot of other satellites come down, what's up with that? And they're like, no, we have to blow this one out of the sky. Turns out it was a really, really secret surveillance satellite that looked like it was going to be coming down on foreign soil, and they didn't want them to have that. So they use a ship-to-air missile, blow it out of the sky, and create 3,000 pieces of debris. Here is 2007, and China wants in on that anti-satellite action. They decide they're going to use a truck-mounted kinetic kill missile to blow one of their own satellites out of the sky, the Fengyun 1C. It creates 3,300 pieces of debris, most of which are still there. That same year, one of the first large constellation operators, so below Iridium, which was the largest mobile phone satellite constellation operator at the time, there was Globalstar. Globalstar launched 48 satellites before realizing that the radio transmitter that they were putting on them wasn't made right, or wasn't in the right bands, and was useless. And so they just went, we're scrapping that program, we're leaving these 48 satellites in space. The year is 2009, and we have, once again, the US going, our networks just aren't keeping up. We'll make a new one. This one is the Space Surveillance Network. Has sensors all over the world, also a few satellite-based ones. That same year, we also have the worst accidental collision in space which we've ever had, the Iridium Cosmos collision between two large intact satellites with a combined weight of 2.5 tons, creates 2,100 pieces of debris. The year is 2015, and the new Space Surveillance Network still isn't doing very well, so a bunch of new commercial trackers get on board. We're up to that point where different companies can start providing those services. We're advanced enough. People know how to build radars. A new company called Leo Labs crops up, who's like, yeah, we're going to build 6 of the biggest, most sensitive space tracking radars that have ever been made all around the world. And then they don't give the US government any information unless they pay $2,500 a month per object to track them. The year is 2018. This new thing called SpaceX has come on the scene, and they want to have the Starlink constellation provide connectivity in all of the remote places of the world. They decide this is going to change the face of humanity and change the digital divide. They conceive of the idea of this mega constellation of satellites. Remembering right now, the limit of a satellite constellation was like 70 satellites. They're like, no, we want 700. Oh no, we want 4,000. No, we want 42,000 satellites to provide cell reception for people. That same year, a San Francisco startup, hot on the trail of this idea that random companies could put things into space, that was kind of getting up to speed then. They want to launch 4 sandwich-sized satellites into space. And the FCC, being the only body in the US that kind of has any sort of control over who puts what in space at that point, goes, no, they're too small, too hard to track, they're just going to become debris. No, you can't do it. That company just pays an Indian launch company to put them in space for them, and they just cop the $900,000 fine. That's nothing. The next year, India wants in on that anti-satellite missile stuff. They launch Mission Shakti, surface-to-air missile, create 270 pieces of debris, blowing one of their own satellites out of the sky. At the same time, the US again goes, this time we'll build a really good radar. This one will work. This is the space fence. At this point, it had been built for 5 years at $1.6 billion and still showed no signs of being completed. It was very, very overdue. That same year, Amazon proved again that using the FCC as the only policing body for satellites wasn't going to work because they just paid their way out of having to adhere to those guidelines at all. The year is 2020. I, in the midst of all the COVID shutdown, start a PhD at CSIRO trying to address this problem. That same year, OneWeb, the second largest mega constellation provider at the time behind Starlink, have launched 74 satellites into space when they go bankrupt. And the US government is like, you should leave some people in an office with skeleton crew, do just enough to track those couple of satellites, and they just don't. So they just leave 74 satellites up there. Most of the planet was shut down. We still found time to put 522 objects into orbit that year. The year is 2021 and Russia goes, we want anti-satellite missiles. They blow one of their satellites out of the sky and make 1,500 pieces of debris. Which brings us to 2022. We've had multiple times this year where parts of rockets or space debris have come down in remote Western Australia, remote New South Wales. We're told that's totally fine. Some papers came out that there's the statistical modeling that showed the odds of someone being killed by falling space debris in the next 10 years, even if we didn't add anything to orbit in the next 10 years, is like 10%. The father of Kessler syndrome as a concept has said it's already too late for us to do anything. It's already started. And they're still telling us that it's fine. And I'm working on it. So thank you for coming to my story. I'm Mars Buttfield-Addison from the University of Tasmania. If you want to ask any questions about more detailed computer science stuff, I'd be happy to take them. I do lots of things related to computers and telescopes, and I also brought some of my books that you might be able to read if you want to learn more about space. Thank you.
We'll keep you in the hot seat for a moment. We'll take a few questions from the floor.
It's not a computer related question, computer science related. I just want to know how they know how many pieces of debris, when they blow up something, how do they know how many pieces it makes?
Well, we actually have these global networks that have to look at the sky every day to keep track of what's up there because of the drag on the atmosphere and the effect of solar winds and all different things, how satellites are tumbling. The way that we track satellites is we look at the sky 24 hours a day and we do constant surveys. So if we know something has been blown up, which usually comes out on international like press channels, we could go and check the sky, but usually they show up on the radars before that happened. Keeping in mind that if we have that number, that tells us how many pieces of debris were detected on a radar that are bigger than about a baseball. Anything smaller than that, we just won't see. And we can only guess at how many would be made based on simulations. So that's how many large pieces of debris showed up on a radar in the next like hour or two. So it's, yeah, probably a horrible underestimation.
So there's a Pacific garbage patch of micro space debris out there somewhere.
Yes.
That's super.
Out there everywhere.
Out there everywhere. Coming down the back.
Do you know if there are any plans on restricting like how much satellites or CubeSats or BBs are, like if there are any plans to restrict how much is sent into space in the future or so?
Yes, so we have, the UN has an office called the UN Office of Peaceful Uses of Outer Space, and they have a lot of work cut out for them trying to write laws that different countries will adopt or that people will ratify. A lot of countries do not want to sign those sorts of agreements because this sort of operation comes under their military umbrella and they don't want to agree that they won't do things that their enemies might. So if we take away that hesitation, a lot of countries are themselves enacting laws, at least for civilian companies, that they're not allowed to launch certain things, which is how we end up with this, the FCC in the US being like, we have this checklist of something, if it's too high risk for debris, we won't let you launch it. But stopping someone from being able to put something in space by just contacting another country, very difficult. And also assessing what is a good enough reason for someone to put something in space. There aren't really any guidelines. Like, as long as it's big enough that it can be seen by a radar, we don't tell people no. Like, there are some random students from the Melbourne University who launched a CubeSat just to see if they could. Like, that's where we're at. Random people can make satellites. No one is going to stop them because we still think that satellites are cool. And I think it's going to become much more of a problem before we have any really harsh deadlines. Like, I can imagine a point in time where they go, no, we're only going to have an assessment of what's really necessary to put in orbit. But still the number of things, if we saw that first slide, like how many services come from things in orbit, even if only the absolutely necessary things were in orbit, we'd still have too much stuff. So it's more about having better methods of tracking them and modeling them, because right now our method of looking with these radars every day, plotting everything's trajectories and seeing if anything's going to hit so we can call the satellite operator and move it out of the way, that's only going to work if our radars get a lot more powerful, the computers doing the simulations get a lot more powerful, and also if we get better at removing anything that isn't maneuverable out of orbit as soon as it's done. But if everything could be moved and we had a really good idea of where everything was up there and really accurate models, then we could operate that safely.
We'll take one more question, and there'll be opportunity to speak to the speakers after everyone has finished speaking. Perfect.
This is a rather whimsical question, but back in the 1930s, a Swedish company designed this ideal instrument for actually capturing these particles and things in space, Electrolux, which is called a vacuum cleaner, funnily enough. But my question is there any proposal to actually get up there and collect this debris? You know, kind of basically.
We have a few key ways. The cool thing about orbit is you don't really have to drag things down. If you slow them down, they'll bring themselves down. So we have a lot of proposals for like getting a little grabber robot that will deploy from a mothership and go and grab a piece of debris and go back. But we also have, we can just like use a magnet to attach a long sail on it and it will slow itself down and fall down. We have lasers, which if something's in really low orbit and we kind of like selectively heat up the upper atmosphere around them, we can sometimes slow them down if they're really small pieces of debris. But all of these things only really work on a per piece basis. And like I said, our estimates are off. We know of a few tens of thousands of large pieces of debris in space, but we can only probabilistically estimate the rest. We think there's about 200 million smaller fragments of debris in space. So this piecemeal approach just isn't going to work. Even if we weren't generating any new debris, which we are, it would take us hundreds of years to catch up. So we need new ways. Even though there are ways, they're not really fit for purpose at scale. Yes, thank you.
So I'm pleased to be able to introduce you to our second speaker, Grace Martini. Grace and I are both colleagues at the School of Geography at the University of Tasmania. It's a department I really enjoy being part of because of the incredible diversity of tea room chatter. Because geography, literally geography, the stuff that's outside the window right now, houses practically every other science, there's room for both myself, striving to understand the complex relationships between insects and their habitats, and there's also room for Grace, who is striving to understand the complex relationship between people and our clothing, understanding the transition of our valued objects as they become discarded waste, and the environmental impact from our current consumption habits. So I'm really pleased to welcome to the lectern, Grace Martini.
Thank you all. It's such a pleasure to get to chat to you about my research today. So as Shasta mentioned, my PhD is in human geography. So I really am looking at both the people and the place relationships that happen around clothes. But today I really wanted to talk to you about my project, in particular, some of the things that I've encountered in my fieldwork, which has all sadly come to an end. But anyway, but really I wanted to talk to you as wearers of clothes, because we're all here today wearing clothes, thankfully. But we'll start off with just a little bit of background around the clothing life cycle, just to give you a bit of an idea. So firstly, on the left here, we've got what's called the linear economy. And that's really what we've got at the moment. And that's known as the take, make, waste model. And really it's about taking resources, making them into clothes, using them, and then they end up, pretty much all of them end up as waste. In some countries, we like to burn waste for energy recovery, but here pretty much all this gets landfilled, which is great. So yeah, it's a very resource intensive model. It relies on a lot of agricultural resources when we're making natural fibers, and it requires a lot of fossil fuels to make plastic, to make synthetic fibers. So all of your polyester, nylon, all of those materials, they're all just plastics. And we use a lot of chemicals in the dye process, and a lot of the effluents that come from that process aren't really managed very well. They're full of a lot of heavy metals, and they're very polluting. Then we get to the use phase, which is when we wear our clothes, and that's really resource intensive as well, because it uses a lot of water, a lot of detergent, and a lot of energy in order to wash and dry our clothes. And that's the most environmentally impactful stage of the entire life cycle. And then of course, yes, as I mentioned, we get to the waste phase where everything pretty much in Tasmania ends up in landfill. Or we do send some portions of our waste overseas to overseas markets, but most of it gets buried in a hole here. And in the middle, we've got the recycling economy. And we have some small examples of that happening, where we do kind of take products, clothing products, and we turn them into other objects, or we recycle some aspects of them. But these are really kind of interim measures, and normally that's kind of referred to more as downcycling, and you only get a certain number of cycles or products out of that before things eventually become waste again. So a lot of people know things about clothing bricks and making different products out of those. That's kind of the recycling economy. We do have some examples of mechanical and chemical recycling. Mechanical recycling really sort of chops up the stuff and respins it, but that yeah, it can only be done a certain number of times. It shortens the fibers, and we end up with waste anyway. And then we've got the third one, which is the circular economy. And that's kind of the dream. We would love to have a circular economy where the idea of waste altogether is eliminated. There's no such thing as waste. And that really means that clothes are designed and made in such a way that they can be disassembled, and they can be either recycled in all their different parts, or they're made in such a way with natural fibers that they can be composted at the end of their life. So there's no such thing as waste, which would be lovely. The problem is we don't make clothes in this way, and we will always have this huge legacy of clothes, all of the things we've ever made that have not been designed in this way, that we will have to deal with and address somehow. So my project, so I'm taking what I'm calling a socio-material approach to clothes. You've kind of got a bit of an idea of why clothes are really terrible for the environment. And they're material objects. You can look inside your tags and you can see that they're made from different material components, cotton, the polyester, whatever. And that's been a focus of most studies of clothing waste. They really look at these material issues and how we can chemically or mechanically deal with these products. And these are mostly studies done by chemists and scientists and which is a really beautiful and big feature of the circular economy that we saw before. And we've also got other studies of clothes from a social science perspective, and they really look at people's relationships with clothing. So we all spent time getting dressed, picking an outfit, maybe deliberating on what goes with what. And it might be really routine, you might not think too much of it, but ultimately we have really intimate relationships with clothes. They're not just about warmth. We signal to each other who we are, what social groups we're part of. It's all these big social components to our relationships with clothes. So we've got these great social studies and we've got these great material science studies, but really I want to try and kind of combine them somehow, because we don't really have any good solutions to clothing waste. And I think part of the problem is we haven't considered these two fundamental aspects together in trying to understand this problem. And so why does it matter? Well, we live on a planet with finite resources, and consumption's increasing and waste is increasing. And we're trying to achieve things like zero waste to landfill targets, but we don't have any solutions for clothes that are actually sustainable. So unless we find ways of dealing with this, we can never achieve these kinds of targets. So hopefully that gives you a bit of a picture as to why I'm trying to bring the social and the material aspects together and why I think they're both really important. So my study is qualitative. I did go out into the field and I dug through a bunch of rubbish, but I really wanted to just examine the clothes and have a look at them and try and understand them. And I went to a whole lot of sites across Tasmania, various waste management organisations, landfills, charity, sorting warehouses, tip shops, the lot, to just have a look at what do clothes look like when they end up as waste, and what are we kind of doing around this? What are the social things that are happening when we're discarding stuff or when they're kind of ending or reaching this end of life stage? So there's no research that's been done on clothing waste in Tasmania. There's definitely not very much that takes this socio-material approach on the mainland in Australia or overseas. So my research became really exploratory. It's hard to anchor your research when there's not a lot else that's been done. So it was quite sort of open-ended. And yeah, I just wanted to get a bit of a general idea of what's sort of happening out there. And I've done an ethnography. Ethnography is my methodology, and if you don't know anything about ethnography, it's a form of, it's a methodology that's situated. It comes from anthropology and it's used to study social and cultural groups, and normally you spend an extended period of time immersed with these groups to try and understand how people do things, why they make decisions, what they think is important, and those sorts of things. So I spent a lot of time at each of these sites, several weeks, trying to figure out what they do, how they do it, and what they think is important, to try and capture that social aspect, as well as doing what I call an artifact analysis, where I was looking at physical objects to try and figure out what they look like, what do clothes actually look like when they become waste. And it was very participatory. So I myself sorted hundreds and hundreds of clothes, and I dug through many, many cubic meters of clothing waste in landfill sites. So full PPE, rummaging through everybody's rubbish, and it was just the best. It was like a treasure trove. So I thought you might find it interesting just to have a little bit of a look inside some of these sorting rooms and get a bit of an idea of what these things look like, some of the things that I saw in these interesting spaces. No doubt all of you have put clothes in the bin at some stage, or you've donated to a charity shop. So probably some of your stuff has ended up in a place like this. And this is a charity store's sorting warehouse. And when things come in, they get placed in these great big cubic meter metal crates, and they're stacked up, and they would have had at least 100 of these in one sorting warehouse. So they all get sent to one place, stored, and then eventually sorted and then redistributed out. And it takes about a year from when something comes in to when it actually gets sorted, because there's so much of it. And so I hope that gives you an idea of just the volume of stuff that comes in. And unfortunately, of course, a lot of this does make it back out to the op shop or wherever it goes. A lot of it does get sent overseas if it's not quite good enough, but a lot of it ends up in landfill. And there's a whole lot of different reasons behind how they classify these things and what they decide should actually just end up in the bin. So here are just a few things that ended up as waste, or nearly, or maybe should have if I hadn't been there. So on the left, it's kind of a bit difficult to see, but there is a dress there, and it's got like a polyurethane plastic top bit, and it's all disintegrating. So when we think back to ideas about recycling, we've got so many mixed component parts in this item of clothing, and there's no way that that's going to be recycled. It's falling apart. There's so many different elements going on. We're not going to take it apart, or it's very cost ineffective to try and take these things apart and recycle them separately. It's got zips, it's got all sorts of things. So that one ended up as waste. In the middle, this is the contents of a bag that I dug out from landfill and rummaged through the contents. And it was full of what I thought were really great winter clothes. They were all different sizes. We've got these two little mittens that they did have their pairs, so they were all there and they were in great condition. And I salvaged these, so they didn't end up in the bin, or didn't end up in the landfill, but they would have if I hadn't been there. So they were probably from a family. They were all different sizes. And yeah, it's kind of hard to know how they reached this point or what happened for them to end up here, but they did. And then on the right here, I've got a black and gold brocade vest, which was in immaculate condition, and I thought was very fun. Probably wouldn't have worn it myself, but I did ask the sorters at the warehouse why that was in the back of the tip truck. And sometimes there's pretty good reasons for this. For example, if it's wet, if people leave stuff out in front of a charity store and it gets rained on, they can't keep it because they can't dry it, and it'll contaminate the rest of the stuff because it'll all get moldy and gross. So, but this wasn't wet, and I showed a different sorter and they were like, that's great, and it went back into circulation. But that, for whatever reason, would have ended up as waste if I hadn't been there at that time, interrupting everything and picking through the bin. And this is a picture of a big pile of clothes at the landfill site. And you can see just in the top left there, peeking out, there's a soda stream in there. That now lives with me. It had a canister of gas in it. And now I have bubbly water, which is great. So as I said, I dressed up in all my gear and my respirator and everything, and I just dug through people's rubbish, and it was the best. But yeah, there were quite a few interesting objects that I found digging through piles like this. There was a lot of, as you can imagine, the Kmart fast fashion junk, basically the stuff that's been worn maybe once or twice. A lot of stuff that had brand new tags on it that ended up there for whatever reason. But there were some other great things that I found as well. I found the most amazing immaculate condition black vintage fur coat, and I could just see this tuft of fur poking out from a pile like this, and I extracted it and thankfully redistributed it to the local tip shop, who promptly put a $150 price tag on it, which I was very happy about, of course. But fur is an interesting one. There's not really a lot that we can do with these kinds of materials. We could probably compost it, but it's probably been treated with a whole bunch of chemicals. that we maybe wouldn't want to compost it. And then you think that it's made with a lining that is most likely synthetic. Maybe it was silk, but probably not. And what are we going to do with these sorts of things? Are we going to unpick them? Are we going to separate these component parts and try and compost some and dispose of others? It's kind of a tricky one. And I also found a really cool set of military clothes. So I found a shirt, a woolen jumper, and a very heavy metal helmet. And I spoke to the attendant about it when I extracted these things. They're all in perfect condition. There were no holes, no stains. You know, you kind of think, okay, maybe if it had a great big moth hole in it, maybe that's why somebody got rid of it. But it's always very bizarre when there's no sign of wear or anything on it. And we thought that it was maybe from the Vietnam War. It was very interesting, and I kind of wondered why something like that that sort of set would have ended up in a place like this. But all sorts of things end up in a hole every day. That's just kind of the reality of it. But hopefully that gives you a little bit of an idea as to why this is such a problematic waste stream. Clothes are really just not uniform in character. There's so many different kinds of clothes, and that makes them really hard to deal with. So what do I think we can do about it? What can we do? It can be a bit depressing thinking about all of these things just getting buried every day, but there are some things that we can do right now ourselves to try and kind of mitigate some of the amounts of waste that are going into landfills. And really, it comes back to thinking about the entire clothing life cycle, I think. At each stage, if we really think about it, there are ways that we can change our relationships with clothes to kind of stem the flow. So it starts really at the beginning. It starts with buying less, because, you know, we consume less will end up as waste. And if we think pretty carefully about the materials of our clothes when we buy or acquire them, if we have things that are made with natural fibers, there's a lot more we can do with them. We can maybe compost them, or they will biodegrade, as opposed to things that are made with synthetic fibers that will take, you know, 400 years, as long as your plastic bottle will, to finally biodegrade. And also, we can take better care of our clothes. We don't mend a lot of our clothes. A lot of them aren't really built to last anyway. But if we think about how we're taking care of them, if we do what we can to kind of extend the life of them, then that will hopefully reduce the amount that's going into landfill. And so there is a lot that we can do on individual and community kind of levels, but of course it's such a huge problem. It's a global problem. Most of our clothes are made overseas anyway, so there's a lot that has to happen at a much higher level anyway to try and kind of really develop better solutions. But really, I think, yeah, hopefully you have a bit of an idea of why it's both to do with our relationships with clothes, our individual personal relationships with clothes, as well as kind of these material science components that are really important. But if we want to kind of achieve these zero waste to landfill targets, we're going to have to seriously rethink how we do it. If we want to use clothes sustainably and be able to continue our relationships with clothes. So that's all. Thank you so much.
Thank you so much for sharing that with us, Grace. We've got time for a couple of questions from the floor before we hear from our final speakers. Anyone need to know more? Madam President.
That was terrific, Grace. I really learnt a lot. But my question is more about the manufacture side, because that's clearly where a big part of the problem lies, because right now, as consumers, we don't have a lot of choice. We're not being offered clothes that can go into those more sustainable pathways. Is your project also going to look at the manufacturing side of things, or would you just like to comment on that part of the problem?
Sure. So I think the manufacturing side, that's really provided a lot of background for my research, and also a lot of the significance of why it's important to look at all these different stages in the life cycle. And there's a lot that's been done. We do these things called life cycle assessments where we measure different environmental impacts across the life cycle, but we just don't really know much about what happens at the end. And I didn't know. And that's kind of, it was very much a personal curiosity. I wanted to know where they go afterwards. And well, really, I started it because I wanted to know what I could do with clothing scraps. I thought somebody must know how to recycle these things, but we don't. So I think the manufacturing side is very important because it sets us up for this end stage. I don't know if that answers your question.
I'm on my way.
Just a quick question that's related more to environmental changes, etc. People, to reduce their energy needs, need to insulate their houses, etc. And most fabrics could be made fireproof by using various chemical salts and whatever. So making basically insulation bats out of discarded clothing could be a very economic way of, like, if you're using fiberglass, for example, it costs so many dollars per square metre, and it's quite. And what you're really doing is just trapping air, kind of. Whereas using discarded clothing waste, wool in particular, like wool insulation bats are almost ideal. Kind of. So I'm just wondering whether someone shouldn't investigate setting up a company to basically produce insulation material from clothing waste.
You should definitely set up that company.
Is it not one of the solutions? You mentioned there's a few of those sort of downcycling solutions where things get regraded into the next life. Is that not one of them?
It's definitely something that should be scaled up, because I think that's probably part of the solution to the legacy of clothes that we can't do much with, we can't really recycle. So I think that that's definitely an option. And yeah, as you said, if you can make them fire retardant so that they're safe, because 60% of clothing fibers are synthetic. So most stuff is plastic. So as long as those things can be incorporated, I think it's a great solution. I think anything that can stem the flow is really good, because there's nothing happening with any of these products. They just get buried in a hole. Yeah.
One last question, thank you.
So you were talking about secondhand clothing. Do you think there's something to be done for the way that we socially think about buying secondhand clothing, or about the way that we're presented with secondhand clothing, that maybe if they were organized in different ways, or if they were marketed in different ways, we might get more people who would buy secondhand clothing as a first option?
I definitely think that we need more attention to secondhand clothes, but we also don't really make clothes in a way that they can have multiple lives. I think for the things that are made well and they're made to last, they should just get kind of circulated between lots of people, so they can be loved, they can be worn, and they can have, what I'm trying to think of the expression. Anyway, the number of times it's worn before it ends up in landfill. But I think there are problems with secondhand clothes too, and that sort of relates to the fashion identity stuff, where we similarly have very high consumption of secondhand clothes, and that's kind of part of the problem too, because all consumption is generally kind of bad, but it's part of it, definitely.